we have entered my favorite unit. I'll say it. When I was teaching, I used to say, oh, I don't have favorites. I love all my units, but I'm really excited about this one. But forget it. It's my favorite unit. We are going to be talking about finding and working with data. And it's going to be so important that we focus on this. And it's going to be so much fun. And it's really one of the things that I think is most overlooked when it comes to working with data. We get so excited about the programming, we get into machine learning that we forget that the data itself is something to be evaluated, to be thoughtfully collected, to be manipulated and cleaned in ways that we hope are reflective of the world that we hope it represents. All kinds of stuff. I'm so excited. So there'll be several videos in this series, but as usual, you should be able to be just fine watching any of them in whatever order or taking and leaving whatever you want. So, all right. I've said before that we don't really know what data is. In one of my very first videos in this series, I said, my assertion is that most people don't actually know what data is. And the reason I think that is, A, I've talked to a lot of people about data, and I don't mean that as a dig on anyone's intelligence or awareness. I mean that as a dig on the images of data that we are given in our everyday lives that look a lot like this, or that maybe look a lot like this, or that look a lot like, it's all blue. Why is it blue? Why is it dots and lines? I don't understand. Sometimes we just have the word big data. It's just not my favorite thing. I don't understand. And then there's language like how our data dreams will finally come true. Chill, bro. We can do amazing things with data. We're doing amazing things with data. I am doing this series to empower all of you to do amazing things with data. But the number one step towards doing amazing things with data is being honest about what data is and what it is not. It is not the stuff of dreams. It is not magical ones and zeros floating in outer space. It's a table. Now, these tables can be massive. These tables can have lots and lots of dimensions. But at the end of the day, most of us working with data are working with data in some format like this, or data that we are putting into some format like this. And I think it's unfair to cast it just as this fancy thing that is untouchable, when a lot of data is absolutely understandable and can be worked with and is available to all of us. And we have a lot to learn from it. So, okay, so this is what data looks like. This is the data that we'll be working with in this course. And it can do really powerful, amazing things, but let's keep our feet on the ground. I know I'm no fun. It's more fun to look at clouds of zeros and ones swirling around, but this is what most of us are working with most of the time. And we can do awesome things with it. First and foremost, I want to say, when you are working with data, welcome to your new best friend. I've introduced several best friends over the course of this series, but tables are your newest of new best friends. We've seen tables here and there. You've probably interacted with tables, maybe even without realizing it. It's the fundamental way that we organize data in data science. So this is an example of a table that reflects a research study, a hypothetical research study from the story of Jon Snow, not Jon Snow from Game of Thrones, despite the characters that I've added here. But Jon Snow was an epidemiologist, the father of epidemiology, some time ago, and he did a study to figure out that people who were drinking from a contaminated pump were getting cholera. So this is an imaginary data set that he might have used. So the way to think about any data set is that it has two components. It has rows and it has columns. The rows are the observations, which is each instance of the thing we are studying. So if we are Jon Snow in this case, and we are doing research on people having an infection of cholera, having been exposed to a particular water pump, and so on, we're going to have people in our observation. So each row is a person and various characteristics about that person. So in the Jon Snow case, every person who is or is not infected in the neighborhood that he was studying. And of course, he includes both infected and not. Quick review. If you've seen previous videos, you know why this is the case. Drop it in the comments and I'll be so proud of you. If you don't, go back and watch video 2 or 3, one of those. The columns are our variables. Our variables are attributes or pieces of information about each observation. We'll call these variables different things depending on the type of analysis we're doing. You may see them discussed as attributes, for example, or features when we get to machine learning, but it's all the same thing. So these are our variables. So each person, Tyrion, Jorah, Sam, and so on, has attributes or things about them that we want to track. Were they infected with cholera? Yes or no? What was their temperature? Did they have a fever? This is in Fahrenheit. If it's Celsius, they're all dead. How old are they? I'm guessing at their ages. Game of Thrones fans come at me. And did they drink from the pump? Yes or no? We are going to work in this course with data mostly stored as pandas data frames. Pandas is a package in Python that we will be using. If you've ever used an Excel spreadsheet, you've worked with a table of data. The key thing to note here is that our rows must be our observations and our columns must be our variables. If you come across a table that is swapped, I'm going to sound really mean here, but be very skeptical of that data because that suggests it was put together by someone who's not so familiar with how data works. And I would want to double check that I feel okay about how they went about collecting the data. So let's talk about how we're going to find data. So, an exercise for you. What is one question that you have that you would like to be able to answer with data? If you've ever taken my course or seen me speak, I love asking this question. There's no wrong answer. Think about it. Pause the video, give it some thought. I promise it's worth it. Now, what would your ideal data set look like for this data science research project? This is the first step in thinking like a data scientist as we start to work with data. So, thinking like a data scientist, scientific method. Before we can even start the scientific method, we have to care about something in the world and have a sense of how we get data about it. In this particular case, I always encourage you to say, oh, I'd love to know more about what makes a successful soccer team or a team more likely to win. Like, great. Okay. What would your ideal data set look like? Or at least a data set that would help you start to study this? Would the rows be soccer teams and the columns be attributes about that team? So I don't know, the age of the coach, the country that they're in. I don't know about soccer. I love using examples I don't know enough about. Part of the fun of data science is you get to work on a lot of different varied projects, and that's why you partner with subject matter experts. Okay. But maybe my analysis should be players rather than teams. Maybe it should be leagues rather than teams, and so on. So take a moment and draw this out. It will really help you concretize whatever it is that you're interested in applying data science to. All right. So suppose you've got it. You say, aha, this is my ideal data set. I'm looking at it. All right. Even if you're not sure it exists, no problem. You turn to the real world and say, gosh, I wonder what data is out there. Congratulations. You've decided to study something. Hooray. Yes, I do my own graphics. Thank you so much. So you have decided to use an existing data set for whatever it is that you're working on rather than collect your own. A fine first start, usually cost effective, see what else is out there. You take to the internet and say, what's available? What data is out there? You'll find possibly data in great shape. That's exactly what you're looking for and matches your ideal data set. You also might find data that's usable, but it's going to need a lot of work, cleaning, combining, separating, whatever, and maybe background research to see kind of where it came from, but usable. You're going to find absolute complete garbage, and we'll talk about what I mean by that you should not use under any circumstances. Or you might find nothing at all. For all the talk we have about data is everywhere and it's the new oil and it's data lakes and data oceans and swirling numbers, there are a lot of things in the world that we care about that we do not have data sets for. I recently wanted to do a research project on the meaning of life, and there's very little data on the meaning of life. There's a fair amount of data on what people think makes life meaningful. The answer tends to be family, boring, but no offense to my family. I was like, there's got to be something. Got to be outer space. That's got to be the answer. But there is very little data on the meaning of life. We'll get to more examples soon, but I promise you it's stunning how many seemingly important things that we think about are out there for which there really isn't much good data, and maybe even none. So, little inspirational words as we dive into searching for data. The only impossible journey is the one you never begin. And the one where the data is garbage and you're out of time. Those are the two impossible journeys. So let's break down the types of data you might find. So one is data in amazing shape, ready to go, relatively rare. Unless you're studying something that's very well studied, you're not going to see much of this. So an example, and we'll be using this data quite a bit going forward. This is a data set of horses, some features of horses and their prices. This was put together by a teaching assistant for Professor Sperling some years ago and continues to be my favorite data set. In addition to the one I flashed up earlier, which is a data set of happiness from the World Happiness Report. We'll revisit that as well. But this is such a fun data set. It's just a teeny snippet from a website of horse prices, but it's a great example of data in stunningly good shape. Not perfect. Notice we have some areas where the values are missing. So under weight, we don't necessarily have a ton of data. You'll also note that it's written out under the weight variable. It's written out as 1,200 pounds, like pounds is written out. That means that it's going to be encoded as a string, and we're going to have to go through and manually change that if we want to find like the mean weight. But the fact that so many weights are missing suggests that we probably want to steer relatively clear or don't hang a lot of our research on that variable. But if we desperately weight is key to my research, then we're going to need to go out and do some more research. All right, so rare, right? It's in our tables. The rows make sense. The columns seem to make sense. They're pretty clear labeled. I can mostly make sense of it. There is documentation online for what we mean by, for example, temperament or disciplines and things like that. Hooray! More often is data that needs some work. So I worked for 538 some years ago, and one of the things I worked on along with several colleagues, Drew Mometa and many others. If you've seen the 538 website, this was as of several years ago when I was working on it. There is a tracker. How popular is a particular president? And it is an aggregate of the answer to survey questions conducted over time by many polling outfits around the country, and a mean is calculated. This seems like it would be pretty easy to turn into data. When I started working at 538, I was like, surely this is all automated and you just like scrape the internet every day and plop these in and it spits out in real time. Alas, no. Even this, which is pretty straightforward, what do you think of the president? The end. Actually required a fair amount of manual work to turn into data. Some websites would reveal the polling data in a numerical format online that we could scrape, but a lot of places, this particular one at that time, released the information in the form of PDFs. And there were PDFs that every single one was a teeny tiny bit different. Sometimes there'd be a number of pages as preamble, sometimes it'd be a different number of pages, sometimes the questions would be asked in a different order, so we couldn't just automate scraping them. So every day, one of my jobs and many of my colleagues' jobs was to literally sit and type in, okay, 26%, 15%, et cetera, et cetera. Notice as well, there's a ton of other data. What was the gender of people who responded strongly approve, strongly disapprove? What was the age? What was the race? And so on. And that's really interesting. But because it took so long to manually put all this data in, and frankly, each one didn't take that long, but there were so many polls coming in all the time that we simply couldn't track the rest of the data. I would love to have been able to go into that initial visualization on the dropdown and say, do it by gender, do it by race. Gosh, wouldn't that have been interesting? We just didn't do it. We also didn't take into account the difference between strongly approve and somewhat approve. Could have been interesting to know. There's a lot that we could have done here, and it simply was too time consuming to track it all. And so we didn't. So usable data, but needs a lot of work. Very common. You'll find data that is not good. My number one rule is that if something does not have documentation or a code book, sometimes you'll see it called a data dictionary, something that describes how the data was collected, what each variable means, what the sample was, who reached out, how it was done. If you don't know where this data came from, do not use this data. There has to be a document, whether it's a website or an external PDF or just something at the bottom of the data set that explains in detail where this data came from, what it actually means. How did the sampling work? Was it random? How was everything measured? More on measurement very soon. What are the potential errors in this data set that the researcher notes and wants us to be aware of? And of course, anything that was collected sloppily with bad instruments, maybe it was unethical or it was biased to the point of not being usable, we also want to throw out. You won't know if it was collected sloppily with bad instruments, biased, if you don't have a code book. You need a code book. The most common is that the data is not there. You want to study something, you go to look for it, and there's nothing. There literally cannot find data on the thing that you're looking for. This feels like it shouldn't be common, but it is. Or maybe there's a version out there, but it's not quite what you're looking for, so you can't quite use it. This is a sign of errors of exclusion. We'll talk more about that very soon. Many reasons that we might not have data about something. One, the thing we want to understand is difficult or complex or abstract. So my example of trying to find data on the meaning of life ran into some trouble because I could find data on what people think gives life meaning, but the meaning of life is a very broad, abstract, complex thing. And so that's a lot harder to turn into a number, not that the former is particularly easy. There may also be ethical, practical compliance issues with asking people questions. For example, suppose I want data on what people in an authoritarian regime really think about their leaders. Boy, you're probably not going to find that data because we can't ask people that because doing so would put them in danger. And another really big reason is normative or socialized ideas about what we should or should not be paying attention to. We'll talk more about this in a moment. But one example of this is research on LGBTQ populations. There's not a ton of data. There's more than there was. But for a long time, it was not a group of people that many social scientists thought was worth keeping track of. And so we didn't have a lot of data for a long time about LGBTQ communities. Many, many other examples out there. And that's just one. More to come. See you next time.